So, short video reply to my comments in the Flex Radio community forums. I've showed you some screenshots with OpenWebRx and GNU Radio using my library for Golang, this flexlib-go. And basically the usage for this IQ transfer tool published on GitHub would be to pull the IQ raw data to OpenWebRx. Let me show you how that looks like. I'm now starting OpenWebRx with IQ transfer utility in the background. You see all kind of status messages from the radio. And there was a message from SmartSDR that a client connected. So we can now navigate to OpenWebRx. The range of the IQ data is a bit too broad, so let me narrow that. Okay. So what we now get is the 192 kilohertz IQ stream directly to OpenWebRx that enables you to share your receiver over the internet while operating. So when I now move here in the spectrum, you see the changes reflected in OpenWebRx, and there's a relative scale at 0 megahertz in the center. That's actually the center of your PAN adapter in SmartSDR. So, kind of cool, but it requires you to operate the radio. And my goal is to have a web client. And I had a first attempt about a year ago using the flexlib based on .NET, and now I'm trying to a second attempt with my flexlib-go. So pretty lightweight and cross-platform. That's important to me. That cross-platform functionality. Let me show you how that works. This is not published because it's really work in progress, and there's not much implemented, and it doesn't make sense to publish this unfinished work. But I can now run a small binary here, and the radio gets used. That's a Telegram bot notifying us when our radio is in use. We are sharing the radio with two other OMs, and basically this Telegram bot monitors the discovery packages from the radio and notifies the group when the radio is in use. So, just a side note. So I've started this HTML5 server, and there's no SmartSDR running in the background. So it's just this binary running. And now I'm gonna start a web browser. And what we see is a spectrum, the PAN adapter, and this is based on the Vita data from the radio. So what I see, this isn't the latest version I'm showing. That wasn't my intention, so let me just start it from my IDE. Then we have to change the URL. It's on my development machine. So okay, now that is the spectrum we are interested in. The red line currently is where the slice is, and you notify this small speaker icon here, and I unmute the radio, and you hear there's audio coming in, and this audio, I gotta mute it. This audio is based on the Opus data stream from the radio, directly from the radio. The data drops in based on WebSocket connections. So let me see if we can find it. Maybe I have to refresh, yes. Okay, so I have an Opus stream for radio commands. I have a WebSocket stream for Opus data, and I have a WebSocket stream for tile data, waterfall tile data. And the waterfall tile data is sent line by line. That is compressed in, oops, that's raw data. We want a preview. I don't know if we can see it on the video. can try to focus. Yeah, it's line by line, coming in line by line. That's quite some data. And it's rendered in an HTML5 canvas element, so you can see the waterfall running pretty smoothly. And the radio here is, yeah, it's 40 kilometers away from me, so it makes it a bit hard to develop. But yeah, that's the kind of direction I'm looking forward to get the radio running over just using a browser. Yeah. So when I now switch to a second computer, so I'm going to a second computer here. Let me change the URL. 178.75. Yeah, just a second. 7.5 and the port is 8,000. Just a matter of hours. So there we go. So now you see it's multi-user broadcasted data. So if I unmute this computer here, yeah, the audio is coming in. Yeah, let me mute that. So yeah, that's the state, how it looks like today, and yeah, stay tuned for updates, but it shows what is possible on the radio. So best 73s.